Hello everyone, my name is Albert Walters and I am discussing the Model View Controller software design pattern for my presentation. I've always wanted to learn about how software works, and this is a topic that I chose to discuss so that I could further learn more about it. This is going to be a broad overview to help concrete the whole idea of the Model View Controller design into the minds of my fellow collegiate pupils. I'm not discussing the actual code on how this is going to be implemented, but instead I will discuss how it works with easy-to-follow pseudocode examples. So I'm going to discuss each separate part of the Model View Controller design with examples, and then bring them together for a nice overview slide with further examples. So to continue on, the model portion of the Model View Controller design is comprised of the data or the elements in the software. The model also contains the data structure necessary for storing the elements, and if necessary, the elements could be sorted, inserted, deleted, searched through, etc. The elements in the model can be accessed with accessor methods. This is something that's typically like get something or, like get size of the elements or get age of a person. The state of the elements in the model can be changed with mutator methods. These change and store new information about the element. This can be something like insert an element, set age of a person, or set the name of a person. It should be stated that the model typically contains no information about how to present the data to a user. In some cases, the elements can be assigned colors in the model or something simple, but is still typically completed in the view. For our model example, let's consider a simple data type that represents our entire model. Let's use an integer counter with an initial value of 0. This counter will be incremented one by one. We're going to need an accessor and a mutator to the data type. This is not necessarily methods, but it will be methods if the model is in a standalone class. Either way, we need a way to get access to the current counter value and a way to increment the counter value one by one. The view is going to present the elements from the model to the user. It is a common misconception that the view itself manipulates the data or the model, but it does not. The view only knows how to access and present the data from the model. It does not necessarily know what the data is, what it means, or how to manipulate it. I'm really trying to drive it home that the view only knows how to present the data. An example of the view is just a normal window or a graphics object. In the window, we would pass the model information or access it in some sense. The window is just a representation of all accessors. The controller in the Model View Controller design is the middleman or the mediator in the situation. It communicates between the view and the model. The controller listens to events that are triggered by the view, like an event listener or an on-click, and it sends the appropriate action back to the model, normally in the form of a method call. And here's the beauty of the Model View Controller design. Since the view is based off the model, the view will automatically be updated after the controller calls any mutator methods. Then a good example for the controller is a mouse click or an event listener that calls the necessary action from the model. From our model example, this could be a call to the public increment method. Then bringing it all together for a nice overview, the Model View Controller is a software architectural pattern that is frequently used to develop user interfaces. And I have two designs that I would like to go over. I feel like they both leave questions unanswered, but they do complement each other well. Looking at the simple design on the left, it is easy to understand that the user sees the view and interacts with the controller. The controller can almost be incidental to the view because parts of the view may be able to be interacted with, like a text box or an element in a simple game. The controller is going to update the model, which will then update the view. To give an example of typing in a text box, you would need a data structure to hold the strings and characters. The text box would be the view, and the text box would also contain a controller that would allow us to actually type in the text box. The controller could then allow us to move it around, change the size, the font, and so forth. As the characters on the keyboard are pressed, they would be added to the data structure or data type that held them, maybe a string. As the user is typing, the keys would be sent to the model, would then be pushed back to the view. This happens almost instantaneously in our modern world. Now, the simple model on the left is too simple to fully understand how this works without further reading. Now, looking at the complex design on the right, it is a little harder to follow since it does not cover where the user comes into play, and it also assumes that the software uses a Java Server Pages template. To start with the model, it contains a database of entities or elements that have certain tasks associated with them, including commands that access and mutate the elements. Accessing and mutating the elements is required for the controller to be able to update the model to have the view updated. The controller is accessed and used to alter the elements in the data structure, which will then update the view. Now we're going to bring together our model example, our view example, and our controller example. And we're going to bring this together for an entire model view controller example all into one slide. Here we have a model class that has accessors and mutators to an integer counter field. The view calls the getCounter method from the model and displays it right in the middle of our window for our convenience. The controller is within the Click Me button. When you click the button, it calls the increment method from the model class. This will then increment the counter field in the model class. And then this updates the view. It's really fascinating to see how this design works. Now, let's see it in a more seamless format from the user perspective. So let's click the button. Click. Wow, look at that increase. Now let's click it again. Nice. This is a really easy to see in this format. It's so smooth that you probably already forgot how it works on the back end. Moving on now, it should be noted that there are many variations to the model view controller design, but every single one uses the structure or the backbone of the model view controller design. It is also common to see the controller within the view class. Since they work so closely together, it is easy to implement multiple controllers in one view. Now, at this moment, I'd like to ask you to pause the video for a moment and think about the following question. Do you think that this architectural design is used in big tech like Amazon or Google? You may pause the video now. And the answer is actually not so straightforward. The answer is yes for Google. Google developers stated that the model view controller design is crucial to designing the Google Chrome apps and they use a CSP-compliant Model View Controller framework. For Amazon, the answer was not so simple to find, but it is believed that they use the Model View Controller design to a degree, but that it is also coupled with serverless microservices. Now, what are serverless microservices, you might ask? These are obviously services for Smurfs that do not have servers, or at least that is the best that I can come up with since I have never learned it, and we are not going to cover it in today's presentation. Thank you for your valuable time and your constant attention. This is Albert Walters, and I'll see you from the skies.